So welcome to distributed systems series. That in this lecture that we will understand cap theorem. So cap theorem. So whenever we talk about the distributed system, we should understand the cap theorem. So it's a way to define the distributed system. First, you will see the definition of cap theorem. C for consistency, A for availability, and P for tolerance. So what does it mean? What is C, what is A, what is P? Let's consider the same example that we seen before in our application. So we have a database which is MySQL. Let's consider it as an SQL database. It's a master DB which stores our data. So we client will write and read data from and to this DB. So client will insert the records to this. So the client will insert the records into this DB and read the records from this DB. Now, if let's consider a simple example, it is inserting the record 1, name and age. This is the name details of some person. So it is inserting this record and again reading this record. So if it can able to read the same data, then the system is consistent. Let's say that it's updating the name to name 2. Now there are, first is an insert, second is an update. After that it will read the data from the DB and it should read this data. So this is the most recent data that is written into the DB. So client has to get this data, not this one. If client can able to read this data, we can consider our system is a consistent. So our system is achieved the consistency. Consistency is that when we write the data and we read the data, we should read the most recent data. That's what this consistency is. So what is availability? So if the machine fails, the master DB fails, that the system is not available. So how to make it is available? How to make it more available? So we can create a slave DB setup. Now the system is more available. It's not 100% available. It's more available. Now, whenever we insert record, it is replicated the data into the slave DB asynchronously. So we insert this record, and this one is replicated. Now this one is replicated here. Again, this data is replicated here. Now we can read the data from the slave machine instead of master machine. This is our setup now. So what will happen here? The consistency is affected and the availability is improved because we write the data, update the data. Meanwhile, we read the data from here. So the problem is here. The one is comes here. Meanwhile, the data is a read from this one is updated here, but it's not reflected in the slave DB. If we read that, we will get this data, not the most recent one. But after a period of time, if we read it again, we will get this data because this data is replicated from master to slave. So now the consistency is a trade-off. We have improved the availability of the entire cluster, but our consistency is not same as a single machine. We have trade-off. We have given a trade-off for this. So what is partition tolerant? Partition tolerant is whenever we have a cluster setup, there are multiple machines are connected with the networks. As a network, there is a possibility that one machine can fail, or there may be a communication failure between machines, or router failure, or switch failure. So whenever it happens, the data from the master may not be able to send it to the slave due to failure here, due to link failure. Data may not be able to replicate it. That's why sometimes we don't read the most recent data, because there may be failure that causing the master DB to synchronize the data to the slave DB. I mean, most recent data to the slave DB. So now, whenever we have a cluster setup, our cap theorem, we can say this is now. Whenever we write the data, if you synchronized with the slave machine and return the response, then there would be any lag in the slave DB. So we don't have any inconsistent data. We always have consistent data. Also, we will have a availability. So whenever the partition tolerant happens, we choose one of the two. Either the system is consistent or available. For the first case, the system is more of available. If you use a synchronous model, the system is more of consistent. So this is a way to define or represent the distributed system. So any distributed system, we can use this scale. So it's not an absolute scale. So this is a more of trade-off based on the scenarios. So based on the synchronous and asynchronous replication, that we can able to say that it's AP or CP. So this is what is cap theorem. Cap theorem states that, so in a distributed system, when network partition occurs and there is a failure between machines, we have to make a trade-off. Either we have to go for availability or consistency. This is what cap theorem is.